Welcome back to another exciting day in Algebra 2. Today we are going to be looking at the binomial theorem and Pascal's triangle. So what is my binomial theorem? Well, this has to do with binomial multiplication. So binomial means two terms. So if I have x plus y and I'm raising it to some exponent, we'll call it n. Now anything to the 0 power is just going to be 1. If you raise it to the first power, it's just itself. And once I get beyond 1, we are familiar with squaring binomials. That is when we FOIL. If we raise it to the third power, we're multiplying it by itself 3 times, and our answer gets a little bit larger. To the fourth power gets bigger, fifth power even bigger, and so what would it be to the sixth power? Well, what if I told you that there was a shortcut that saved you from having to do the multiplication by hand over and over and over again? So this is the binomial theorem, which is kind of confusing and scary to look at. So there is a shortcut that was invented called Pascal's triangle that helps with this. So the first thing I want to draw your attention to, though, is when you're raising your binomial to a power, the number of terms in your answer is always going to be your exponent plus 1. So when my exponent is 0, I have 1 term. When my exponent is 1, I have 2 terms. When my exponent is 2, I have 3 terms, and on and on. This is important to help us determine where in Pascal's triangle we need to look. So we're going to look at this to figure out what is x plus y to the 6th power. So this is your typical binomial theorem. I'm not even going to go into what all of this means because we're just going to use Pascal's triangle. Now, Pascal's triangle, you start with 1 at the top, and your next row, every row gets 1 more term. But your first 2 rows all just have 1s. And everything along the outer edge of your triangle will also always be 1s. The way you fill in the middle is you add the 2 numbers above it. Well, 1 plus 1 is 2. So I have now completed that row. For my next row, 1 plus 2 is 3. 1 plus 2 is 3. I've completed that row. On this one, I'm going to have 4, 6, and 4. Then I'm going to have 5, 10, 10, 5, 6, 15, 20, 15, 6, 7, 21, 35, 35, 21, 7. So you could keep going infinitely, but let's talk about how many, like what degree of exponent this would get us to. Well, this would be to the 0 power, first power, second, third, fourth, fifth, sixth, all the way up to the 7th power. So if I wanted to go to the 8th power or beyond, I would need to fill this in more. So this is my triangle. What this is going to tell me is the coefficients in front of all of my terms. So remember, as I expand out my terms, I've got exponents, but I also have coefficients in there. What Pascal's triangle tells me is the coefficients. So let's look here. I've got x plus y to the 6th. That means 0, 1, 2, 3, 4, 5, 6. This is the row I'm looking at. And I'm going to have 7 terms in my answer. Remember, you have the number of terms that is your exponent plus 1. So I'm going to have 7 terms here, and we're going to figure out what each of those is. So I'm going to start by having x, y in each of these terms. X, y, x, y. Okay, so there are my 7 terms, and now I'm going to put my coefficients in front. So I've got 1, 6, 15, 20, 15, 6, 1. That is what I use Pascal's triangle for. Now what I need to do is my exponents. So I'm starting at 6. So I'm going to start with my exponent on x at 6 and take away 1 every time. So 6, 5, 4, 3, 2, 1, 0. Once I get to the end, I'm going to start over with y. So 6, 5, 4, 3, 2, 1, 0. Now, if I had a coefficient on my x or my y, that exponent would also apply there, and that's where other binomial theorem problems would get trickier. But for this problem, all I need to focus on to simplify this is where I've got exponents to the 0 power. Remember, anything to the 0 power is just 1. So my first term, this is just going to be x to the 6th, 6x to the 5th y, plus 15x to the 4th y squared, 20x cubed y cubed, 15x squared y to the 4th, 6xy to the 5th, and then on my last term, this is just going to be y to the 6th, because I've got x to the 0, which is just 1. So here is my final answer, and I was able to use Pascal's triangle and my exponent pattern to find the answer without having to multiply over and over and over again. So let's do a few more problems on the next page. We've got Pascal's triangle up here at the top already for us, and this is going to be 0, 1, 2, 3, 4, 5, 6, up to the 7th power. So to start off with first, I just have a minus b to the 4th. So this one's going to be tricky because I have that minus in there. But again, 0, 1, 2, 3, 4. This is going to be the row I look at for my coefficients. And I'm going to have 5 terms. So I'm going to start there by just getting my 5 terms. So I'm going to have a negative b, there's 1, a negative b 2, 3, 4, and 5. Then I'm going to look down my row at my coefficients. So that's going to be 1, 4, 6, 4, 1. Then my exponents with a starting at 4, 3, 2, 1, 0. Then backwards for b, 4, 3, 2, 1, 0. So for my first term, this is just going to be a to the 4th. For my next term, I've got negative b to the 1st power. So my coefficient in front is actually going to be negative 4, then a cubed b. Then I've got 6a squared negative b squared. Now when you have a negative times a negative, that becomes positive. So when you have even exponents, it becomes a positive value. So 6a squared b squared. On the next one, however, I've got negative b to the 3rd. So that's going to be a negative times a negative times a negative, which will give you a negative output. So when you have even exponents, your output will be positive. But when you have odd exponents, it will be negative. So this is going to be negative 4ab cubed. And then again, a to the 0 is just 1. And I've got negative b to an even exponent, so it's just going to be b to the 4th. Okay, on the next one, I've got x plus 2y to the 5th, which means this is the row I'm going to be looking at for my coefficients when my exponent is 5. And I'm going to have 6 terms, so I'm going to go ahead and get those 6 terms out. I've got x, 2y, 1, 2, 3, 4, 5, and 6. What's going to be tricky about this one is remembering that whatever exponent is on the y, I also need to apply that to the 2. So I'm going to go ahead and write in my coefficients here. I've got 1, 5, 10, 10, 5, and 1. Then for my exponents on x, 5, 4, 3, 2, 1, 0. Then for y going backwards, 5, 4, 3, 2, 1, and 0. So for this first one, I am just going to get x to the 5th. For the next one, I've got 5 x to the 4th times 2y. Well, that 5 and 2 is going to give me 10 x to the 4th y. On the next one, I've got 10x cubed and then 2y squared. Well, when I square that 2, that's going to be 4. The 4 and the 10 will give me 40. x cubed y squared. On the next row, I've got 10x squared, and then I'm cubing 2y. That means 2 cubed is going to give me 8, and the 8 times 10 will give me 80. X squared y cubed. On to the next one, 5x, 2y to the 4th power. 2 to the 4th is going to be 16, and then 16 times 5 will give me 80. So 80xy to the 4th. And then on the last one, I've got 1 times x to the 0 is just 1, but the 2y to the 5th, I have to do the 5th power on both. So that will be 32y to the 5th. Okay, I think I can do one more before my timing runs out. I've got the 6th power here, so this is the row I'm going to be looking at for my coefficients. And I'm going to have 7 terms, and they both have a 3 on them. So this one's going to be really fun. So there's 1, 2, 3, 4, 5, 6, and I am running clear out of room here. Let me get some scratch paper for the 7th term. Okay, there is my 7th term. I don't know if you can see them all. Okay, there's my 7th term. So my coefficients is going to be from this row, 1, 6, 15, 20, 15, 20. Oops, I went too fast. 1, 6, 15. And my whiteout does not want to cooperate. Okay, this one's going to have some big numbers if you can't tell already. So let's move on to putting in our exponents. So on this first one with 3z, I'm going to have 6, 5, 4, 3, 2, 1, and then 0. And then working backwards, 6, 5, 4, 3, 2, 1, 0. So let's just zoom in and go one at a time. For this first one, 1, 3z to the 6th, and this is just going to be 1. Well, I have to raise the 3 and the z to the 6th power. So that is going to be 729 z to the 6th. That is 3 to the 6th power. Moving on to the next one, I've got 6 times 3z to the 5th. That means I'm going to have to raise 3 to the 5th power and then multiply it by 6. And then not only that, after I raise 3 to the 5th power and multiply it by 6, I still have what is going to end up being negative 3 here because I'm raising it to an odd power. So this is going to end up being negative 4,374 z to the 5th y. Again, this number came from raising 3 to the 5th power, multiplying it by 6, and then multiplying it by negative 3. Moving on to the next term, I've got 15 in the front and then 3z to the 4th, which means 3 also has to be raised to the 4th power, and then negative y squared. So squaring this is going to give me a positive 9. I'm going to have 9, 15, and then 3 to the 4th power is going to give me 81. So 15 times 81 times 9 is going to give me 10,935. And I've got z to the 4th y squared. There's my third term. And I'm running low on time, so I'm going to pick this up in the next part of the video.